Okay, so Brewster's law, Brewster's angle, this is the angle at which the light gets, the unpolarized light gets polarized, right? So this is the, you can see this is the representation of the unpolarized light, right? It has vibrations in all possible directions perpendicular to the direction of propagation. Okay, so this is the unpolarized light. However, when this light gets polarized, then the vibrations will be restricted to only one single direction, which is perpendicular to the direction of propagation. So when this unpolarized light is being incident at an angle theta, where theta is the Brewster angle, so when the light is incident at Brewster angle to the interface, then the a portion of the light is reflected and a portion of the light is refracted, and this reflected and refracted light, it is polarized. It is polarized in nature. Okay, so this angle is related to the refractive index of this material which is there at the interface, and the relation between these, the refractive index is tan theta b is equal to mu2 upon mu1. Okay, where mu2 is the refractive index of this material upon which you are making the light incident, and mu1 is the refractive index of the the medium which is above the material. So if it is air, if the material above this medium is air, then this should be 1. Okay, so tan theta b is equal to mu2 upon mu1 is the Brewster's law or the Brewster equation. Mu2 is the refractive index of the reflecting surface and mu1 is the refractive index of the surrounding medium. Okay, so now how to do this experiment? If you go to this simulator part, so you are given with the accessories over here. Okay, so you have to arrange all these accessories. For example, you have an emitter, you have a current output unit, you have a detector, you have a polarizer, you have a material holder. So detector means when the polarized light is being detected. Okay, so this is used to detect the polarized light. Output current unit means this is used to measure the intensity of the current, how much current is being passed. Okay, so when the light is polarized, when the light is completely polarized, you will get the maximum current, but when the light is slightly polarized, you will get the less current. Okay, when it is unpolarized, you will not get the current. So emitter, this is the emitter which is emitting the unpolarized light. This is the polarizer and this is the material holder. Okay, so this is the emitter, this is the polarizer which is used to polarize the light, this is the material which may be glass, which may be topaz, which may be any kind of reflecting surface. This is the detector which is used to detect the polarized light, and this is the output current measuring unit. So here this is the enlarged scale which is showing you the angle at which the material is kept, this reflecting material is kept. Okay, so you can just see the side view and the surrounding medium. I have selected it as air, let's say. Then the material, let's say this is topaz having refractive index 1.6 07. Okay, so angle, let us say I have kept it at in the beginning, let us say this is minus 90 degree. So when you switch on the light, and after switching on the light, you just fix the position of this reflecting material. Okay, so this position of this reflecting material can be fixed by changing the angle of incidence. So when you change the angle of incidence, you can see in this current output unit, the current which this unit is being receiving is changing. Okay, so when you change the angle, you will see that the current goes on increasing. This is 9 point something, and now this is 10.60. Now this is 10.91. Now this is 10.97, 10.99, 96. So now you see this, that now it is decreasing, right? It means that the reflecting material is not at proper angle. Okay, so we have to look for the maximum value of the current which is being received by the current receiving unit. Okay, so if you go beyond that, you can see the current again decreases, so you have to look for the maximum value. So this is 10.69, 10.79, 10.8, 93, 97 and 99. So this is the maximum value of the current you are receiving from this setup. Okay, so at this value of the current, you can see the Brewster angle is this one, 58.11. Okay, so this is the value of the Brewster angle for the air as the surrounding medium and topaz having refractive index 1.607 as the reflecting surface. Okay, again you can change the reflecting surface. You can use the crown glass. This is having less refractive index, so when you use the crown glass, you just switch on the off the light first and then you switch on the light again. So you can see the value of current over here is 10.98. So if I just move this pointer slightly ahead, this is decreasing. Okay, so it means 10.98 is the maximum value. Okay, so here now the Brewster angle value is 56.66 degree. So you can see that the value of the Brewster angle is directly proportional to the refractive index, right? Earlier when we used topaz, the refractive index was higher and the value of the Brewster angle was also higher. Now for this crown glass, the refractive index value is lower, so therefore the Brewster angle is also lower. You can also check with the other one, flint glass, which is 1.57. Switch off and then again switch on the light, so you can see the value of Brewster angle is 57.51. so it means that Brewster angle is directly proportional to the refractive index of the reflecting material, right? So this is what you have to do. You just use different you take air as medium, then you take all three reflecting materials. Okay, you find out the Brewster angle for all three, make a table, then you take uh, helium as medium and then repeat the experiment, take the all three values with this, so, right, and then you take the another medium, hydrogen, maybe then carbon dioxide. So you have to choose the medium and then you have to take the Brewster angle value for all these three things. Okay, so this is what you have to do. Make a table, एक टेबल बना लो, ठीक है, और उसमें एयर के लिए पहले लिखो रिफ्रैक्टिव इंडेक्स इतना आ रहा है, फ्लिंट ग्लास के लिए इतना है, क्राउन ग्लास के लिए इतना है, टोपास के लिए इतना है, उसके बाद फिर ऊपर दूसरा मीडियम ले लो, हाइड्रोजन ले लो, फिर नीचे इन तीनों की वैल्यू लिखो, फिर तीसरा मीडियम लिखो ऊपर, फिर नीचे तीनों की वैल्यू लिखो. So this is what you have to do and finally do an analysis जरूर करना है, ठीक है. एंड एनालिसिस में लिखो कि क्या फ़र्क पड़ रहा है जब आप मीडियम चेंज कर रहे हो तब क्या फ़र्क पड़ रहा है, और जब आप रिफ्लेक्टिंग मटेरियल चेंज कर रहे हो तब क्या फ़र्क पड़ रहा है, राइट. सो दिस इज व्हाट यू हैव टू डू. क्लियर स्टूडेंट्स, एनी डाउट? Yes students, in doubt?